Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called group anagrams. So in this problem we have been given a list of strings and we have to group the particular anagram. So let's take these strings in our whiteboard here. So EAT, TEA and TAN and ATE, NET and then BAT. Okay, so let's say these are all the numbers that we have been given. Anagram is nothing but if we shuffle the characters around and if we are getting the different valid word, then that's called anagram, right? So if we observe here in the green color like EAT, right? And if we are just placing the character here and there, then T we are just moving before E and A. So this new word is TEA, right? And that's also anagram of EAT. Similarly ATE is also we are doing the same thing, right? So TEA, if we are swapping T and A, not in fact T or A, we are just what we are doing, we are just uh, ATE, right? So A we are just moving before T, right? So if we just change the location and if we are making the different word, that's the definition of anagram, right? Similarly, if I take like blue color, so TN and NAT, they are also anagram. Similarly, like different color, let's say the black color, BAT is the one word, but there is no corresponding anagram, but we want to group it separately as a one word, right? So considering the definition, now this is the part of the problem, and then to solve this problem what we can use the fact of anagram that if we change the location of the character then we are getting the different word, right? So probably what we can do, we can just sort the word. So for example, if I take this word EAT, right? So EAT, if I sort the word, then I will get the word AET, right? And if I get the AET, right, and there are different similar words that's they are making with the characters A, E and T, and those words are TEA and ATE, right? So these are the two and these are the three words basically that I just painted with the black color. So if we know that fact that we have to use the same character, right? So what we can do, we can just take the additional data structure that's called hash map or hash table, and in that hash map we can just use this as a key. And why key? Because this would always be same, because we are sorting, and then this word AET will always be same. And then once we encountered EAT and we know that it's part of AET, so what we can do, we can just add this EAT, we can attach this EAT with our key AET. Similarly TEA, and once we sort TEA we will get AET, and we will know that AET is the key of TEA, then we can attach this TEA with the AET. Similarly ATE also we will sort, then we will get AET, then we can attach this ATE in with the with AET itself, right? So that's how if we sort each and every word and then we figure it out, okay, this is the key, and then similarly we can just keep adding those values. So like for example TAN, right? And TAN, if I sort, then I will get okay, so A and T, right? A and T I will get, so this will become my key after sorting. And once I encounter TAN, I will just attach this TAN with ANT, and similarly NAT I will attach with this the same thing. And as BAT does not have any corresponding anagram, so BAT we can just group it separately with another list, right? So that's this is the approach, and this is just an idea that this is how we can solve this problem. But let's quickly create couple of placeholders and then we can just come back here and we can try to understand more if it is needed, right? So as discussed, the approach would be like just to create the hash map, right? So let's take first of all resultant list. So let's say this is our result list, new array list, right? And let's take the map. So map key will be my string that I will be sorting, and value I'm just taking as a list. Why I'm taking as a list? So that I can attach. So if we saw here, we are just attaching this key and we are attaching all these words, so they are making as a list, right? So these words are itself, they just look like as a list, right? Similarly, tn and entity, they are also look like as a list. And another reason is basically because we anyways we have to this list of string here, right, as a selected part, and all these groups basically are nothing but they are itself as a list. So that's why we are just taking as a list, right? And if I do like this, and then let's go ahead and iterate this array here. So let's do that, strs, right? And then what we can do it here, str do char array. Why we are doing that? Because we can convert every string in a character array so that we can easily sort. And for sort, just use built-in method of Java, that's arrays.sort, and then just sort this array. Once we are able to sort this array, then just take it as a key. So let's take another variable that's called key string as a key, and our array would be as a string. So I'm just converting this character array into the string. And the reason, basically, I can, some people may prefer array dot to string, and that will give us the object, but that this will not convert the array to the value, right? So for example, my character array is car, right, car, right? And if I do this dot to string, then it will create something underscore to alpha numerical, right? So it will just give me the object, but it's not going to give me the car, right? So that's why I cannot use array dot to string, right? So don't use array dot string, right? I'm just appending the comment here because it will return object but not value, right? Now once we get this key, then go ahead and put this key, attach this key to the new array list. So key and comma new array list, and map dot get key, and then dot add, just go ahead and add this string. That's it, right? So that's what we are doing. We just created AET, and from AET we are just getting this AET, and then whatever the list is there, in the list we are just adding all these characters, right? EAT, TEA, and AT, right? So that's what we are doing here. Now once we are able to do that, I think we are good, right? Because in the map itself, it will have this new array list, and in this new array list we are just adding another optimization, or I mean the better code. What we can do is new put if absent. So put, basically the difference between put and put if absent is put will replace the existing key, right? And put if absent is like if this key does not exist, then only it will add, otherwise it will not, it's not going to add new array list, right? So we really don't need to replace again and again. Once we get for example, in this case, if we get AET, we will initialize the new array list at the first time only. Once we get again AET for different word, we don't want to create the new list again, right? So what we will do, we will just use the same list here, and in the same list we will just get this key and we will get the list, and then we will be adding that corresponding string, right? So once we are able to do that, then we are good, right? So in the map with every attached key, we have all these lists, right? So with AET key we have this list, with ANT key we have this list, and then for the different BAT itself will have one list, and that will have the BAT itself, because there is no corresponding anagram, right? So what we can return, we have to return list of list, so new array list, and then map dot values. So map does dot values is nothing but they are all the list itself, and because we have to wrap all these lists within one list, so that's why we are taking new array list and then map dot values. Quickly check for compilation error, or is there any other typo that I did. So let's see. So ATE, EAT, the difference is coming because of the reason because they are not in the order that I expected, but it's fine because in the note section they are saying that order of your output does not matter, right? So we should not really bother about the output order of output, but we should be bother about the accuracy or correctness of our output. So EAT, TEAT, and BAT, and TAN, and NET. So they are grouping as expected. Quickly check for the time complexity and the space complexity. So our time complexity will be linear here because we are just iterating till this array length, and space complexity would also be the linear because we have to maintain this additional map, and then we are using this map, and similarly we have to maintain this new array list. In fact, we don't need this res because we can just simply return if in fact we don't need this as well, because you know what, if even if it is null, then what it's going to do, it's not going to iterate it here, and we are just returning this map dot values, and this will be null. So let's quickly see if it is going to submit, or if there is any error we can course correct that. Okay, so this is looks like it's getting accepted. So as a summary of this problem solving here is there are a couple of takeaways. One is like we have to first understand what the anagram is. Once we know the definition of anagram, that it's nothing but if we are shuffling around the character and we are making the new word that's called anagram, then we can take that fact as a consideration and we can just sort every word, and then we can make it as a key, because that's not going to change for all these corresponding words, right? So if I paint it red, right, EAT, that if I sort all these words, that will remain same, and that's what I'm making as a key. And with every key I'm just appending all these words, basically separating, and that they are making as a list itself. So every map values is having the list, and that's what I'm returning in the last, right? So hopefully this is useful. Thanks a lot. Have a good one. Bye.